Welcome. In this video, we'll learn how to graph the equation y equals x minus 3 squared. As always, a graph is just a set of ordered pairs, and we can use the equation to tell us which ordered pairs are on the graph. Let's generate a couple of ordered pairs to get a feel for how this equation works. I'll choose x equals 5. Replacing x with 5, we get 5 minus 3, which is 2, and 2 squared gives 4. So the ordered pair 5, 4 must be on this graph. Let's try a different value of x. How about negative 4? Negative 4 minus 3 gives negative 7, and negative 7 squared is positive 49. So the ordered pair negative 4, 49 is also on the graph. Next, let's take a close look at the table of values for these two functions and see what we can learn by comparing them. Along the top, we have values of x, and on the bottom row, we have values of y corresponding to the red formula. For instance, 3 squared gives 9, and 4 squared gives 16. In the bottom table, again, values of x are along the top, but this time we're using the blue formula, x minus 3 squared. For example, 6 minus 3 would give 3, and 3 squared gives 9. 5 minus 3 would give 2, and 2 squared would give 4. Okay, now let's look at the y values in each table and see what we can learn. 0 occurs exactly once, and each other y value occurs twice and is symmetrical around 0. We can make the same observation about the y values in the second table. 0 occurs once, and the rest of the numbers occur twice and are symmetrical around 0. What's interesting is to compare where that symmetry occurs. In the top table, the symmetry occurs when x is 0, whereas in the bottom table, the symmetry occurs where x is 3. Let's go a little further with that. I'll just underline values that are the same in both tables. Y is 1, y is 4, and let's compare the x's that produce those same y values. In the top table we have 0, in the bottom table we have 3. In the top table we have 1, in the bottom table we have 4. In the top table we have 2, and in the bottom table we have 5. Notice that in each case, the x values that produce similar y values gets 3 higher. 3 higher than 1 is 4. 3 higher than 2 is 5. And if you think about it, that makes sense because we had to subtract 3 from x before squaring the number. When we go to graph the equation, we'll see that the entire graph is actually shifted 3 units to the right. And this demonstration helps to demonstrate why that is the case. As a shortcut to know where the symmetry value occurs, we can ask ourselves, what value of x will produce 0 when we subtract 3? And the answer is, of course, 3. That can help us to know where this interesting thing happens. In fact, I'll use that observation to my advantage right now by centering my table around 3, knowing that 3 minus 3 is what would give 0. Let's go higher than 3, and let's go lower than 3. And we'll do the x value minus 3, and then square the answer. 3 minus 3 is 0, squared. 4 minus 3, squared. 5 minus 3, squared. 6 minus 3, squared. 2 minus 3, squared. 1 minus 3, squared. 0 minus 3, squared. And now we're all set to start plotting ordered pairs. For instance, we'll plot 3, 0, 4, 1, 5, 4, and 6, 9. On the other side, we get 2, 1, 1, 4, and 0, 9. For the sake of comparison, let's make some dots for the function y equals x squared. Notice that's already in our table because 3 squared is 9, 2 squared is 4, etc. So we're just plotting these ordered pairs. Okay, now for the interesting part. As we said in the previous screen, all these x values that produce the same y's are 3 higher. And the graphical consequence of that is that each blue dot is 3 units to the right of each red dot. Cool stuff. Okay, let's actually trace the graph of y equals x squared so we have something to compare our graph to. And now let's sketch the graph of y equals x minus 3 squared, which goes through all these blue dots right here. And there you have it, the graph of y equals x minus 3 squared. A couple of observations. The graphs of these two functions have exactly the same shape. They're both symmetrical U-shaped curves. But this graph is no longer symmetrical around the y-axis. Instead, it's symmetrical around the line x equals 3. And to understand why the action happens around x equals 3, we can again notice that's the value that makes 0. And that's where the symmetry occurs. Shoom, shoom. Okay, to push yourself further, try to understand what the graph of this function looks like. And if you're feeling brave, try to figure out what the graph of x plus 4 squared looks like. And then actually try it. Thanks for watching.